Hello, in this session I am going to take the fundamentals of machine tools and operations. First we will take definition of machine tools and different machine tools such as lathe, milling and drilling, and in that I will take the construction and working principle of lathe in this video, and next I will take the other two machines, milling and drilling, and various lathe operations such as turning, facing, taper turning and knurling, thread cutting I am going to discuss here. The machine tools. Machine tools are defined as power driven machines which accomplishes the cutting operation or machining operations. These are the power driven machines which are carry out, that is, different cutting operation or machining operations. In that, the lathe. A lathe is a machine tool employed generally to produce circular objects and perform various metal cutting operations such as turning, pacing, taper turning, knurling and thread cutting. This is the construction and working of the principle of lathe. The lathe mainly consists of bed which supports for all the parts of the lathe, and headstock where it is all gearing and driven mechanisms are present, and that is called as a live center also, and it consists of the driven system as well as the gearing for the rotation of the check. This is the check. Okay, these are the jaws of the check which holds the job or a workpiece firmly in it for rotation and for the machining operation. And other end, it is called as a dead center or tailstock. Dead center or tailstock. In this one, it consists of a ram, the supporting point, and the ram movement wheel and ram clamping. And again, it consists of the carriage, okay, which supports for the cross slide, that is a tool post slide, we can say, cross side and tool post slide, and the tool post where we can fix the tool for the operation. It consists of the screw rod, feed rod, and the engagement of the screw cutting engagement lever for this one, screw rod engagement, and feed engage, and carriage wheel, this one for the movement in the transverse direction along the axis of the this lathe. And in this one here, the workpiece weld here, that will be supported at the other end by the dead center, and whatever the tool in the right angles to direction, the depth of cut is given, the feed is given along the axis of the lathe and for the operation, and whatever the cutting chips are there, that will falls in the tray here. Like this operation of the lathe will be taking place, and the different operations what we carry out on this lathe machine, those will discuss one by one. The main components of lathe: bed, headstock, tailstock, carriage assembly, main drive, all we have discussed. Lathe operations, those are the turning, facing, taper turning, knurling, thread cutting. First one, turning. It is an operation in which the workpiece size is reduced to the cylindrical section of the required diameter. That means by this operation, the outer surface material of the workpiece is removed and its diameter will be reduced. Okay, here this sketch shows that one. This is the check. In the jaws of the check, the workpiece is held firmly and the tool is facing against the workpiece, and the surface material that is removed from this one. The depth of cut is given right angles to the axis of the lathe, and the feed is given along the axis of the lathe. And here the tailstock is used for the supporting of the workpiece. And here this is the original diameter of the workpiece, and after the machining, this is the reduced diameter of the workpiece. By turning, we are going to reduce the diameter of the workpiece after the machining to the required size. The next one is the facing. The facing is the operation performed on the lathe to generate the flat surface. Okay, here to produce a flat surface, we are going to machine whatever is there, that is called as a facing. Here direction of the feed is perpendicular to the axis of the lathe. Here in this direction we are going to give the feed, and in this direction we are going to give the depth of cut. And here The same way in the chuck, jaws of the chuck, workpiece is held firmly, and here other end is not supported because from the face only we are going to remove the material. That's why here the tool is held against the workpiece at the face material is removed, and the face flat finished surface will be produced. Okay, that is the facing. The next one is a taper turning. Here it is the operation of reducing the diameter of the workpiece gradually along its length. Gradual reduced diameter we are going to produce in this one. That is the taper turning. In this one, the one side of the workpiece is having the larger diameter, other side it will having the smaller diameter. The tapered surface will be there. That's why to produce the tapered surface, whatever the turning operation we are going to carry out, that is called as a taper turning. There are different types of the taper turning. One is a compound rest swelling method, the other one is tailstock offset method. This is first one, which is a compound rest swelling method. In this one, the compound rest whatever is there, on that the tool post is mounted, that can be swelled at any particular angle, and there is a adjustment is given on that whatever the compound rest is there for its movement. And for that, here the angle of swelling whatever is there, okay, that is depending upon the smaller diameter and larger diameter and length of the workpiece, how much it is required. And for that, the calculation of that angle will take here, and for that how the operation is there, we will take, and the angle will discuss later that one. First, in the chuck, jaws of the chuck, workpiece is held, and here the taper is to be produced, and for that this is compound rest whatever is there, it is tilted at a particular angle alpha. That angle is also mentioned here, the circular base with the graduations. On this there is a circular base with the graduations, there the angles are mentioned. At that particular angle it is fixed, and it will be tightened with a bolt. And here the feed will be given in this direction, depth of cut will be given in this direction at an angle, and here the hand wheel where it is there in order to give the depth of cut. And for this angle whatever we have mentioned here, and also that angle will be there on this circular base, that is calculated by this formula. That one, here we can see that one, this is the larger diameter and this is smaller diameter, this is the length of the workpiece where the taper surface is to be produced. And for this diameter and length we are going to use to find that angle, that is angle alpha is equal to tan inverse of d minus d by 2l. Okay, here d is the larger diameter, d is the smaller diameter, l is the length of the workpiece for which the taper surface is to be produced. And after calculation of this angle, this will be fixed, that one on the circular surface, that angle will be set, and that will be compound rest will be tightened. Then the operation will be carried out in order to produce the taper surface. This is the first method, that is a compound rest swelling method. Then second one, the tailstock offset method. In this one, this is the live center, that is the headstock of the lathe. The other end whatever is there, that is a dent setter or a tailstock whatever we call, that is offsetted at a particular distance. And this offset distance whatever is there, if you set, then the whatever this workpiece is there, that is at a particular angle it will be there. Okay, its axis will be at a particular angle with the axis of the lathe. Okay, and that angle will be here alpha, it is given. Here we are going to calculate the offset distance, how much offset distance we required for this tailstock. That offset distance can be calculated by using offset k is equal to d minus d by l. The d is the larger diameter of the workpiece, and d is second letter d will be the smaller diameter, l is the length of the workpiece. And by this one we are going to calculate this offset distance, and that tailstock is set at an offset and that is fixed. Then later how the that is a turning operation we are going to carry out along the axis of the lathe, like that the depth of cut will be given, and continuously we are going to that is turn it, and by that we are going to produce the tapered surface. And here this is the whatever this feeding is there, in this direction it will be depth of cut we are going to give by using that is whatever the tool connected in the tool post. By that we are going to produce the tapered surface. The next operation is that knurling operation. Knurling is an operation to impressing a pattern straight or diamond on workpiece. with a special tool called knurling tool. Here the impressing is some pattern on the surface of the workpiece. Okay, by either it may be straight or a diamond shaped, and for that purpose we are going to use the special tool that is called as a knurling tool. The tool consists of upper roller and the one lower roller, which contains the impression. That upper and lower roller, what are there, those will contains the impression. The same impression will be produced on the workpiece. The tool is set in such a way that both rollers touch the work. The tool whatever is there, that should be set in such a way that the both upper and the lower roller should touch the workpiece. For this one, we are going to take that it is the check. In that jaws of the check, workpiece is held over the surface of this workpiece. We are going to produce that is a knurled surface, and for that the special tool, knurling tool, we are going to use. And for this, the depth of cut we are going to give here from initial to the final finished product, and the feeding will be given in this direction. Okay, so that both the rollers will be having the touch with the workpiece, and continuously if it is fed that one, the impression will be produced on that one. Whatever the impression is produced, that may having the angular pattern, diamond pattern, or a straight pattern. Okay, depending upon the which pattern it is required, we are going to use that type of tool. And this is required whenever grip is required on the workpiece to hold properly, and for that purpose we are going to use this knurling. The last operation is that thread cutting. Thread cutting means here a thread is a helical shaped groove formed on cylindrical surface of workpiece. The helical shaped groove has to be formed on the cylindrical surface of the workpiece. Thread cutting is an operation performed on lathe to produce a threads by using a tool whose shape will be same as that of the thread. Okay, the tool whatever we are going to use, that shape should be what shape of the thread is to be formed, that shape we are to use. That means here this is we'll discuss here while taking that tool. But here the first in the check, this one in the jaws of the check, workpiece is held and other end is supported by the tail stalk or a dead center. The whatever the tool is there, here tool is having the V shape. We are going to produce a V shaped threads, and that if you have that is square shape, this one, the square shaped threads we are going to get. The any shape here, the different shape we are going to have, then different shaped threads we are going to form here. Those should be standard. The feeding will be given in this direction, depth of cut will be given in this direction. For this purpose there is a special arrangement, that is engagement of the feed rod we are going to get. Okay, that feed rod whatever is there, that should be screw rod, that should be engaged. Okay, initially I told you that one, the screw rod engagement, there is a separate lever is there. If you engage that one, the automatic that carriage will be move along the that workpiece axis. Then here the cutting of the thread will be taking place, and the reverse also we can have the movement. Then later the continuous operation will be taking place in the forward and reverse motion, and later at the end we are going to get the finished thread on the surface. Okay, this is about the thread cutting on the lathe. Thank you, and continue to watch some other machine tools in the next session. Thank you.